Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Now, I just got done recording the episode on standard map versus my hand-rolled simple constexpr map to try to prove a point about some of the possibilities of using constexpr in your code for compile time known data. This episode's going to air at least a few weeks after that episode. But I started thinking it's entirely possible that the astute observer to this channel would notice that I was using map.at here, which is a potentially exception-throwing function call, and might think, wait, is that slower than just using the index operator? So I have to discuss why I used map.at, the differences between at and the index operator, and whether or not that there is actually a performance difference between calling these two things. Now, the first thing that we should note is that if I call using just this index operator, this is approximately the code we left off on here before, I get a compile time error. Passing const map blah 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 ignores this argument, discards the this argument qualifiers for const, basically. I'm trying to call a non-const member function on a const object. So to make this compile, I have to remove the const. And if you've been programming in C++ for a while and using the standard library, you've almost certainly been bitten by this at some point or another. So if we have this const here, and this is, well, history lesson first. Of course, the excellent cppreference.com should almost always be your go-to resource for this kind of stuff, looking for this information about C++. So we want to go into the containers library, we want to look at map, and we want to look at this operator bracket, this index operator. This is non-const functions here. We'll get back into what that means in just a moment. But we have an at function that is const and non-const versions that was added in C++ 11. This is consistent with what standard vector has offered for a very long time. And basically, it returns the value that was referenced, or it throws an out of range exception. So before C++ 11, if you're old like I am, then you would end up having to have done things like, oh my goodness, before C++ 11, we didn't even have auto. So it would look something like if my map this iterator and I try to find the element in here. We ended up doing code like this all the time. And then we would, oh no, why didn't this compile? We would then, oh right, we have to actually return the second because the iterator is an iterator to the pair of elements here, which is the string view and the int. And finally, it compiles. And then after we got C++ 11, we could have done something like const auto, or as you saw previously, the at. So let's go back to that version real quick. And it looks like this. This is effectively what I just did with that find and all of that nonsense and throwing my own exception if I wanted to, because I had to deal some way with the fact that I did not have a valid value to return. I can't return -1 because -1 could be a valid value in this lookup table. So that was incredibly frustrating before C++ 11. Then we get the at function. The at function does that. Now, what you're probably still left wondering, or possibly still left wondering, is why in the world the index operator couldn't have just worked. Why is this a non-const function? So let's go back. And if we look at the bracket operator here, we will see this function is equivalent to this. It returns, it inserts the value if it doesn't exist, and then it does return the value that it either inserted or it already existed in there. So it is equivalent to having to do a make pair of this key with the defaulted value. So if you had something without a default constructor, that's already a problem. The fact that it's not const isn't just an additional problem on there. Call make pair of that thing, call the insert function into the map, and then return dot first arrow second. Oh my goodness. So insert returns a pair of the iterator versus comma boolean, and the iterator is the location of the element, and the boolean is whether or not it had to insert a new element to get you where you are. And so then that pair, I have to access the first element. That's the iterator that was returned, arrow second. So I am saying now give me the second element of that iterator pair iterator pointing to a pair that was just returned from the map. So it is always, always, always trying to do an insert. So what is the actual code difference here? Does this generate different code? Does it have different performance? Let's figure that out. So we're back here at this version. Now I'm going to take away the const here so that everything is fair. And we're just going to take a quick look. We've got this index operator lookup here, and this is generating 823 lines of disassembly output. Now some of this is the lookup table or the data table, and some of it, well, yeah, that's going to be constant here throughout this. So not a whole lot of it is fixed data. So we can kind of just round that off. It's 823, but if we wanted to, we could come up to here and say it's 774. Now let's change this to .at, which is considerably more simple code. It's more the code that I wrote earlier, where it does a find and then it just returns the value or throws. It doesn't have to do this whole insert thing. So this is now 496. Or if we scroll back up here, 448. So we're talking about, what, 2/3, a little less the size of the one that used the bracket operator. So something to think about. Does this have an impact besides making our binary bigger? Let's see. So we were just looking at GCC's output with O3. And I am back here in QuickBench, this awesome tool for helping us to compare these two things. And I'm building on this comparison that I had been doing with the const_expr map earlier in that previous episode. I suggest you check it out if you haven't before. And I'm going to make this all fair here. I've got a non-const map just in case the compiler had decided to do some weird optimization with the fact that it was const. And again, I'm in standard map. And I'm doing .at here. And I am doing this index operator lookup to on this bottom one. Now keep in mind that this bottom one might be inserting values. We have no way of knowing if it's inserting new values that are all defaulted to the value of 0. So that's weird, but we just want to do a comparison here and give you something to think about when you're writing your C++ code. So we already know that we've made a binary savings. Let's see if we get a runtime savings. Okay, so it just ran. I've got it on the assembly side here, so there's no giveaway, but we already know that there's a pretty significant difference in the difference in the size of the assembly generated. At least that's what we saw before. Let's see. Yeah, we can actually visualize it here. If you notice right over here where the code ends, so the at is generating much less code than the index. Let's compare it, and look at that. It is equivalent to standard map.at. Interesting. Now I will say that I have run this benchmark before with different compilers and different options, and let's see what happens if we switch to Clang. So with Clang here, we do see that there's a slight difference. The at is a little bit faster than the index version. And if we try libc++, then I'm seeing even a slightly more improvement here, 1.1 times. And for those of you who are curious, does adding const here make a difference? This was, no, this is a previously saved value that I had and previously cached one. If I make it GCC and I do const, we might see some difference here in jitter. So what we're effectively seeing is the .at is sometimes a little bit faster than the index, and it makes sense that it should be because it is doing less work. It's never trying to insert the value, and it's always generating less code. So it's probably more often what you actually want to do, and definitely something that you should think about when you are writing C++. This is not the same as calling .at versus the index on a vector, because it's never a checked lookup on a vector when you use the brackets. And it is when you do the at, but it has to do the same kinds of, it has to do the same kind of work. It actually does less work with the .at with the map. And again, we're seeing something like 1.1 times. It's very, very similar. So yeah, thanks for watching this episode of C++ Weekly. I hope you enjoyed this and learned something new as usual.